Well, thanks for coming. I'm glad to see all of these faces in here. And we've got quite a few on Zoom as well. So good turnout for our second lecture in the 24-25 series, where we have combined our group with the Sauk Prairie Conservation Alliance. And I'm Dan Hulling. I'm with the Badger History Group. So just out of curiosity, how many here are here for the first time for one of the talks from the Badger History Group? All right. Great to see you. We have 4 more coming in the future. So thanks to Heather, who does our tech work over here and allows us to have this in the hybrid format. So thanks also to Concordia United Methodist Church, who has provided us this venue. And I said last month, I reminded people that were here that it's kind of fitting because Concordia is the sister church to the Telke Evangelical Church out on the Badger property that was shut down in 42 with the coming of Badger. And this lectern that Frank is sitting behind was comes from that church. So we got one more person joining us. So yeah, that's kind of cool to have this little piece of history here. Please, a reminder to please hold your questions until the end. And if you're on Zoom, you can type them into chat and then we'll ask them at the end. And also for those on Zoom, please mute your mic and keep your video off if possible. So tonight's talk on the modernization of the ammunition plant by Frank Wolf will be a delight, I think, for any of Badger history fans. This is a subject that hasn't been talked about before in any of our talks we've had. So Frank is a chemical engineer with nearly 6 decades in the energetic material industry. 6 decades. And that means things that go boom, basically. And Frank's resume is a long one, so I'm not going to share all of it, but he was the BAAP Chief Modernization Engineer at the Badger plant for 31 years and is currently the treasurer for our Badger History Group and on the board of directors. He has been involved in local history, especially his hometown, that giant city to the west of us called Mazomanie. And he has written...
Hey, you pronounce it correctly.
Okay, good. He has written 7 books on history and genealogy. This is Frank. I believe this is your 5th lecture for our group, something like that. And the focus tonight will be the period between Vietnam and the shutdown. So the last 2 times I've introduced Frank, I've started with a joke about engineers. And I thought it would only be fitting that I keep that trend going. So the optimist sees a glass that's half full, and the pessimist sees a glass that's half empty, and an engineer sees a glass that's twice as big as it needs to be.
That's partly correct, Fred.
All right, so it's all yours, Frank.
Thank you all for coming to the lecture tonight. I hope everybody can hear me. There's not one of these speakers here, so sometimes people say I talk too loud, and other times not so loud. Yes, I worked at Badger for a long time, and what I'm talking about tonight is something like 40 or 50 years ago. And, you know, I'm an old guy now and I sort of forget things, so I probably am going to make some mistakes. But I see a few people in the crowd that if I do make a mistake, let me know. And I've tried to make this as not a technical discussion about modernization. It's in general sort of about what the whole program was all about. So I hope you can learn some things tonight. The title says after Vietnam, but the modernization program really started during the Vietnam War, during that operation. Also, I need to alert you that this computer system here is new to me, so if something funny happens here, I don't know nothing about it. See, it already. Okay. 3 people helped me in preparing this lecture. I want to acknowledge our archivist, Verlin Miller. He helped me with some of the pictures. Then Ori, he found some of my old reports that I hadn't seen in 40 years. And then Dave Fordham. Dave Fordham was the plant manager, plant engineer when the program started. I used some of his old files to get the proper dates and the various projects that were in that original modernization program. You probably know Dave Fordham as when he was the plant manager, but he started out here at Badger as the plant engineer. Hey, the agenda. Here's the agenda for this lecture. I want to describe what the modernization program included, what the time frame was, and the various costs. Now, these costs are quite variable. They're really big numbers, but they're still variable because we didn't have control over all the numbers. They were government numbers. And compared to today's numbers, take these numbers that I give you tonight and move the decimal point over once. 10 times more expensive today if we were to do some of these things. Then there'll be a description of the projects that actually happened. There'll be a lot of pictures of the buildings and the equipment, and then I'll have a quick summary and then answer questions. What was the modernization program? In Dave Fordham's words, quote, "The modernization program is a large-scale, multi-year program. Essentially, this program will replace most existing production facilities," unquote. These existing facilities at Badger were built in the 1940s with 1930s technology, designed to last only 5 years. Then after 30 years, the facilities had deteriorated and worn out and had gone through 2 wars. Meanwhile, there were advances in technology that provided new processes that produced product better, cheaper, less safety hazards to the operating personnel, and also they improved the environmental situation. The initial 1971 to 1980 modernization program. 10 years from 1971 to 1980. That's how long, that's what the initial program was. It was to cost $385 million, 27 separate projects. Now remember, Badger is one of 25 ammunition plants. And all the other ammunition plants had modernization programs similar to this. So you can see there was big money, really big money. And by today's standards, even bigger money. So, and here is a listing of the initial modernization program with its 27 projects. The projects are listed with the cost and the year of funding. The first projects in yellow are the only projects that were actually completed. Those 5 yellow projects up there are the only ones that were actually completed. In the darker yellow, they were sort of partially completed. See, up here's the year, 1971 to 81, and then you got 27 projects going down here. Yeah, kind of small, but I think you can get an idea that there was a plan, and it was going to be money every year, $385 million. And we only did 5 that actually were completed. There were 2 that we did some work on. We did a lot of design stuff on some of these other ones, but some of them were just the concepts. But that's what that initial 10-year modernization program looked like. Is that correct, Paul? So in here is where these projects were going to be. Now it's probably kind of hard to see, but here's a view of the map of Badger showing where some of these facilities are going to be. Now you look over here, here's where the main office building was. And one of the projects was to build a new administration building, a 5-cornered building, right there where the old maintenance area was. Here's the first powerhouse number 1. Here's the firehouse, which is still there. Then the new acid complex was out here. And there's going to be a new nitrocellulose complex right here. The nitroglycerin area, that stayed in the same place, only it was modernized. And then single base was going to be all this area here in the northeast area where nothing was ever there, and there were going to be new facilities put in here. Laboratory and ballistics used to be over in this area, was now going to be here. Here's the reservoir up on the hill. And then down here is the new shops area, was going to be right in the middle of the plant. The rocket area stays in the same place, although it's modernized, and the ball powder facility stays in general in the same place, but would be modernized. And then the burning grounds would be moved over to the eastern side of the plant. But you can see there was a plan to have these new facilities all over the middle of the plant, rather than where they were initially built. The initial plan never happened like it just showed you. There were many changes. The time frame doubled to 20-year plan from 1971 to 1992, and then it expanded a little bit beyond that. The total cost increased to over 600 million, and we only spent about 10% of that. Various utilities and environmental projects were added, increasing the total projects to 55 projects. The modernization changes happened in 1976. Major changes to the plan are shown here. Justification. We attempted to change existing facilities with the following priorities that you see here. Economy of production, make things cheaper. Safety of operation, safer for the operators. Better pollution control. We knew at that time that we had to get better at that. Reduce noise. Overcome production deficiencies where we couldn't make something that we needed to make. And then elimination of a production bottleneck where we didn't know how to do something. Here's a listing of the 7 projects actually worked on. The last 2 were only partially completed, as you saw from the previous little chart. Design and preliminary design work was completed on a lot of projects. You see, we had a 400 ton per day ammonium nitric acid plant, 2 different nitric acid, sulfuric acid, NACSAC acid plants, two of them, a 350 ton per day oleum or sulfuric acid plant, a 2,500 ton per day per hour, 2,500 pounds per hour nitroglycerin plant, I got to tell you a little story about that. When we were trying to prove out the nitroglycerin plant, you got to do something with the nitroglycerin you made. Well, what are we going to do with it? Well, we thought we could sell it to the people that make the nitroglycerin that goes into the tablets for old people to make your heart beat better. Well, running our plant 2 hours and we had a year's supply of nitroglycerin. So, I mean, we had to run it something like at least a shift or a couple of shifts. So we got so damn much nitroglycerin. So we never did do a real prove out to make nitroglycerin, which is probably good. The first project. First is the 400 ton per day ammonium nitrate plant, AOP, where we make nitric acid. We made 62% made nitric acid from ammonia. We make 62% nitric acid. The modern one reactor plant replaces 750 ton per day small plants. The new process reduced the NOx, nitric oxide, pollution from 2,000 parts per million to 200 parts per million. And that, at that time, was within the pollution abatement limits. And the number of operators dropped from 2 to only 2, one on the line, out in the process, and one at the control panel. This is a little schematic that shows what the existing plant was up here at the top and what the modern plant was. And here you have all these compressors, which I'll be showing you a picture of, all these old compressors and a bunch of reaction vessels here in this house. And you replace that with one compressor and one reaction vessel. So you're eliminating a whole bunch of things, replacing it with one big thing. More on the AOP project. It was a chemical construction, that's the company's name, design, and they're from Canada. The design was completed in July of 1975, and the construction started in July of 1973, was completed in August of 1978, 5-6 years there. And the first prove out happened in August of 1979. And from that first prove out, then there was some, in this case, there was only a few minor corrections that had to be made. Here's a picture of the old AOP nitration building. Big building made out of wood, and wood and nitric acid don't go together too well. So we're starting to come apart. Here's that old AOP compressor. I understand Paul has 6 of these now?
No,
No?
one other side, we didn't get an electric one,
There's one in your steam,
it's in pieces.
it's in
Still
pieces. But you can see this big wheel here is about 6 foot in diameter. And there was a belt that went across here, down around here and back. And it was driven by an electric motor and compressed air here. And compressed air was pumped into the reactor and mixed with where it was mixed with ammonia. And this is replaced with a new AOP plant. And this is looking towards the west. The administration building is out here. Here's the main road coming in. And here's the reaction vessel is right down in here. Show another picture of that. And this is absorption tower, and that's 180 feet tall, I believe, something like that. Then here's the storage tanks after you made the nitric acid. Here's another picture looking towards the east. Here's that a big absorption tower. The operating building is right behind the speed limit signs. And these are ammonia tanks here Ammonia was brought in by rail. And then this big building is the knapsack building. And that building is, I believe, 150 feet tall. Very big buildings compared to the old ones. And over here in the corner, you can see the little edge of the main control panel, the main control building. And the controls for the entire acid complex were in this building. Here's during construction of the AOP. This long train here is the heat exchanger. The actual reaction vessel is right here, this vessel here. And here's where the platinum gauze, where the ammonia reacted with air. And this, in the old facilities, this vessel was about 32 inches in diameter. And this one is around 6 feet in diameter. As you can see, quite a bit bigger. And what's not shown here is the compressor, but I got another picture of that. This is during construction. This is after construction. The picture was taken as the equipment was taken off site after the demolition. That entire compressor or reaction chain was put on one big truck and shipped off site. And this is the one vessel that replaced the 7 in the previous ones. And here's the reaction vessel. And there's where you put your couple of $1 million worth of platinum in there to use as a catalyst to react ammonia with air to make nitric acid. That's quite a truck. And I'm not sure where that went, but it ain't here no more. I had heard that it went to China eventually. I know the plant went to Louisiana to start with, and from there I think it went to China. There's that big compressor, and this is about 6.5 feet in diameter in here. It's driven by steam. And there's just one of these compared with 7 of the old batch process. Here's the control panel for the entire new acid complex. I'm not sure which one is which, but the 60 feet long. And you got the AOP, the oleum plant, and the knapsacks are here. Everything's controlled from here. Each plant, there'd be a desk here with the operator. They're watching all this instrumentation here. And at that time, it was back in the 70s, 75, 80, this was a very modern computer controlled process. But nowadays, it's somewhat not quite so computer controlled the way the plants are nowadays. Where the operator, he had to, you can see buttons here, he had to push buttons to make changes. Well, nowadays he would be sitting at the desk here and he would have a computer in front of him and he'd push a few buttons and things would happen. So this is very modern, but not as modern as things are today. Next is the 350 ton per day oleum or sulfuric acid plant. It makes 40% sulfuric acid from various liquids and solids. The modern plant replaces the obsolete plant that just made nitric acid from sulfur. The new process reduced sulfur dioxide from around from about 2,000, 3,000 parts per million down to 200 parts per million of SO2. And it reduced the number of operators from 4 to only 2 per shift. 1 out in the area and 1 sitting at that control panel. Here's another little schematic. The oleum plant, a lot of tankage, parts, sulfur storage, And the more modern one is much more simplified. I don't remember exactly which one is which here. This oleum plant is also chemical construction design company from Canada. The design was completed in 1975 and the support construction started in 1973 and everything was completed in August of 78. And then we had a prove out in August of 79, and there were some minor corrections that had to be taken care of. Picture of the new oleum plant looking towards the southwest. What you see out here in the background, that's the ball powder area. And here's the reaction vessel where you burn sulfur to make sulfur dioxide. And all this tankage in here takes that sulfur dioxide or solutions of sulfurs, of sulfuric acid and concentrates it up to 90%. Here's absorption tower for I call SOX, SO2, SO3, where you change it into sulfuric acid. And there's our storage tanks for the product. This is on the south side of the acid complex. Here's another picture of the oleum plant towards the north, looking towards the north. You have the big knapsack building over here. And here's the sulfur burners behind here. Here's the reaction vessels for the taking the sulfur dioxide and making it into oleum. Sulfuric, very strong sulfuric acid. This building right here there's the control building for the entire complex. And this is absorption tower from the AOP plant. So you're seeing the entire modern acid complex looking towards the north. Next project, the knapsacks. Nitric acid, sulfuric acid, concentrators. This plant produces 90% sulfuric acid and 98% nitric acid. And it replaces these obsolete units. The new process reduced the NOx air pollution down to 200 parts per million, which at that time was the limits. The number of operators was reduced from 4 to 2. One person out in the plant and one person on the control panel. Here again is another little sketch of the plants. You see there's separate neck sack buildings, process buildings, a lot of takeage, different parts to it where you all put all these buildings into one building. This shows the three of them, but they're all in the same place, the same building. A little schematic showing you go from a lot of processes down to a single process. These knapsack plants were also chemical construction design from Canada. The design was again completed in July of 75. And they started construction in 73, and construction was completed in 78. And again, there was another initial prove out 79, and they found a few errors. They were a little more serious in this case, but there were errors that were found. New picture. Here's what the building looks like. You've seen it in previous pictures up here, the big building, about 150 feet tall. It's filled with things in here, which I'll show you another picture of, but here's a good picture of the control rooms for the entire acid complex. There were also offices in here for management, and there's a maintenance shop on the bottom floor. Maintenance shop for the acid complex. Here's storage tanks from the nitric acid and the nitric acid absorption tower. Back here is a big big cooling tower. Here's what it looks like inside, 250 ton per day knapsacks. And you can see it's kind of looks complicated. Well, it is complicated. We had seemed to me about every kind of metal that you can think of. There were titanium tanks, titanium pumps, molybdenum was used a lot. These exotic metals that went into this facility. And there was also this tank over here, I believe, is a lead tank, old-fashioned lead tank. I remember we took a group of Boy Scouts into the plant and show them all this, and I was worried because when you get way up at the top of this building, you can look down 150 feet, and these Boy Scouts running around there, they're curious. They want to try things, look at all over. And I didn't like that. But when I told them, look out there, that's a lead tank, now all of a sudden they get away from that. Lead's bad for you. Well, at certain concentrations, yeah, and you shouldn't lick it. But then who's going to lick the side of a lead tank? Here's another picture on the inside. All kinds of piping all over. And, well, I don't want to get into details that what's what, mostly because I'm not sure. Here's our nitroglycerin plant, continuous nitroglycerin plant, 2,500 pounds per hour. The modern plant is a continuous process that replaces 2 batch nitrators. It is remote controlled with the control panel located 150 feet away from the actual nitrator. The modern plant has new facilities to improve the safety of the workers. That's by making it remote control. And the number of operators dropped from 3 to 2 on a line, 1 in the control room and 2 out, just moving through the area. Here's another little schematic. You can see you replaced people with existing facilities with that one guy sitting at a control panel, running the whole thing, and the other 2 guys just walking through the area to see that there's not a problem someplace. People versus safety. The nitroglycerin plant was a modern plant from the BHG design, and BHG's from Switzerland, but the actual plant was built in Italy. The design was completed in July of 75, and construction, like the other plants, in 75 to August of 78. And the first prove-out happened in August of 1979. And as I mentioned before, the prove-out, all we did was make water. We just made sure all the instrumentation worked, but we didn't make any real nitroglycerin. But we still needed some minor corrections. Here's the old nitroglycerin area, and the new plant was built right on top of it. Here's the 2 batch nitrators, 1 here and 1 here, and then the transfer lines down to the storage buildings here, and then down to the process buildings where you load them up into the wheeling walk and what's the buggy's name I'm looking for? The what?
Angel buggy.
Correct. The angel buggies on the wheeling walks down to the rocket area. And the new plant the new plant, the production building was sort of put right in this area here, and then the storage buildings are down in these areas, down in here, of which, if you know where to look, one of the storage buildings is still there. I guess when they decided whether it was worth demolating or not, it was so difficult to demolate these buildings because these buildings were built to contain a nitroglycerin explosion of 12,000 pounds of nitroglycerin, which is an awful lot. So you got a lot of concrete, structural steel in the concrete, and it just was apparently not worthwhile demolating, so they just kept it there because it was never contaminated. So it's a brand new building but if you know where to look, Dan will be able to tell you where it is. But it's off the beaten path. You got to look hard to find it. There's what an old nitrator looks like. He's sitting there putting glycerin into nitric and sulfuric acid, and he's holding on to the line that holds the glycerin flowing into the nitrator. And as you can see, that might not be exactly the safest thing one could do. If he doesn't pay attention and he makes a mistake, well, that's the way it is. The new BHG equipment, it's all mounted on one wall, a stainless steel wall, and here's the reaction vessel where you put the glycerin into the acids, and the mixture flows out into this, swirls around and separates, where the spent acids that are left goes down here, and the nitroglycerin overflows, goes into these washers. All this is happening continuously. It's washed 3 times, and then it washed nitroglycerin goes into this vessel, and that's where it's educted with water down into the storage areas. New BHG design. And since it's made in Europe in Switzerland, they made it all look fancy with all this fancy decoration on the side of the vessels. Over here in the United States, we don't make vessels fancy like that because it serves no good purpose except looks nice. Here's the new BHG remote control panel. Here, you're 150 feet away from where the nitrator is happening, and also taking care of the storage areas. There'll be an operator that sits at a desk here and operates from these 2 panels. Next project, the next modernization project is the first of 4. It was going to be 4 nitrocellulose plants. None were ever completed. The modern plant was a continuous process that replaced 8 batch units. That's each plant. It was remote controlled. It was to be remote controlled. The modern plant was to have new facilities so they would improve the safety for the workers, and the number of workers dropped from 20 down to only 9 per shift. Here's another little schematic showing what the existing facility and the modern facility look like, where you have a guy sitting at a panel watching things happen, and where you had in the existing facility, you had people physically doing things, moving the product around. This modern continuous plant was a Hercules design developed at Radford Ammunition Plant. The initial design was completed in 1975. Construction never started. Only a few process vessels and some pumps were bought. We redesigned the process to be installed in Badger's F line during 1987 and 91, but again, we never constructed anything. It was just designed. Here's that old batch nitration down the reaction vessel down here. That's the dipper. Anybody here who used to be a dipper?
Mine,
Huh?
relax, no.
Well, what he's doing is he's got a fork, a lead fork where he's forking the cellulose. This is ground up paper, cellulose into the reaction vessel. And there's 9 of these, I believe, in a building.
Probably 44.4 pounds. In the
Whoa.
town.
Remember, 44.4 pounds per. Yeah. And here's what the new process was going to look like. That dipper guy, he's replaced with a continuous vessel where doesn't show it on here, but the cellulose will fall into right in here. Here's the acid mixture coming in. You can see it's a 4-story building with the acids coming in the top, the reaction vessels on the 3rd floor. Then from there, it would drop down into the centrifuging and further processing. And here's the control panel. They would take care of the operation of the entire process. They would, from here, would get shipped out to a single base area or to ball powder. That was going to be put into F line, which is the line, the nitrocellulose line farther south. The last modernization project that we actually did quite a bit on was a mechanized rocket facility. That design was developed at Sunflower Ammunition Plant, and the initial design was again completed in 75. We never purchased anything in this particular facility. We never constructed anything, but we later developed our own automated rocket finishing facility, but that came later. This project was to modernize the entire rocket production area. But again, only the finishing area was really, we did it our way rather than Sunflower's way. The modern rocket finishing was a continuous process that replaced existing obsolete manual operated batch units. It was remote controlled. Modern facility was remote controlled. And the new facilities, they improved the safety of the workers and also the quality improved. With only the finishing area modernized, the number of operators still dropped from 9 to only 2 per shift. The finishing area modernization was completed and proven out in July of 1994. That was the last significant amount of work we did with the modernization program. Here's what the old finishing spiral wrapping looked like. Well, you had a manual person would take material from here. This would be the rocket grades that were extruded, bring them over and put them in here, and then they would they would manually cut them off to certain sizes, and then they would further on down, they would wrap ethyl acetate plastic around them and run them out here, and you can see a couple of the rocket grains laying in here. All that was done manually. Having trouble with my last page. A summary. Summarize, we completed only 5 of the original 27 projects. We partly completed 2 others. We spent something around 53 million or something of the originally planned 600 million. The time frame was 24 years from 1971 to 1994. And we never did any actual production. And by that I mean we made product for several months and it went to use for the Army. We never really did any actual production in new facilities. Even the acid we made, and we made quite a bit of acid, we shipped someplace else and somebody else used it. It was never used here for our own production. And that's the end. Thank you for listening. Are there any questions?
They explained that oleum is basically a super sulfuric acid. So we have sulfuric acid, which is like in your car battery, and you get up and we said you go to the sulfur, you burn sulfur to sulfur dioxide, and they gave it a little more oxygen over some vanadium pentoxide catalyst, and you come up with sulfur trioxide. Well, the sulfur trioxide plus water equals sulfuric acid. So I guess that actually putting the sulfur trioxide into the sulfuric acid was the better way to make it. Then you just add water to get instant acid.
Yes, oleum is sulfuric acid that's 105% sulfuric.
It's something you can add, but it said,
10?
the 108 or something on there, but it doesn't seem to compute out right, but. Yeah.
And when you heat it up, it fumes and it's got red vapors.
It's so sure about the red, that's more so nitric, but you think that sulfuric acid is well, oleum is 10 times worse than sulfuric.
Yes.
It is bad.
It automatically starts reacting to the moisture in the air, so you get fumes right away if it's exposed to anything.
A side issue is sulfuric acid is the most made chemical in the world. As chemicals, sulfuric acid.
Well, they do like 2,000 ton a day plants. Maybe
Oh,
more.
yes, nowadays plants are magnitude bigger than what we,
Well, I think our plant was the most complex plant probably about ever made, but it certainly wasn't the biggest.
yes. Yeah, the same can be said of the nitric acid plant. I think the biggest one nowadays makes 5,000 tons per day. And they got several reactors all put together and they got gigantic compressors, trains, and things are just really big nowadays compared to the way we had them out here at Badger. Yes,
Right, we have a question from Zoom. David asks, why were the majority of the planned projects never done? Who decided not to follow the plan?
that question I've been asked a lot. I think it was never done because the Vietnam War was running down and they thought they could get by without doing this modernization. Plus the modernization was such a large number, because remember now we got a 500,000 or 500 million and you got 25 plants. So you got really big numbers. The quantity, the dollars were just too much for what they thought they needed at that time. And the government made the decision. That's a big word. You might say the Department of Defense probably made the big decisions. We did not make them.
On the BAAP system that we used during the Vietnam War. As I understand it, it was made on demand. the BAAP system was a continuous process. How did they control, how would it they control, it never ran for production, but how would it be to control that without storing it someplace, or would they store it someplace and then move it to raw powder and to rocket?
No, it was continuously made, but it went into a storage tank it's 4 storage tanks. Each storage tank, I believe, was like 12,000 pounds.
That's why it's concrete.
Yes, yes.
Did make
And the continuous process, you could start it up or shut it down within like 15 minutes. So you could, when everything got full, you shut it off. And it was very easy to do.
David on Zoom asks, another question, which plants actually got the modernization and which exist today?
Well, I can, the one that exists today is Radford. That's like ours. And Sunflower, I believe, has a little bit of, they had modernization also. Some modernization, but it was sort of like ours. It was not entirely the big program. I don't know of any plant that had the entire program that modernized everything like they said they were going to. I don't know if I answered that, but
Talk more about the advantage of going from a batch process to a continuous process in these different lines.
yes. That was the big modernization, was taking these batches and making into a continuous. And by doing that, you can, you cut down on the amount of energetic material that's in any one spot at the same time. Whereas a batch system, like the nitroglycerin, you had this 10,000 pound charge that the guy sitting there holding the glycerin in. Well, when he's done, he's got 10,000 pounds of nitroglycerin that he's sitting on. Whereas the continuous process is something like 5 pounds in the vessel going through at any one time. Big safety difference. And that's the value of the continuous process versus the batch system. But some other minor things, like each batch can be a little bit different. And if you're doing it continuously, you're sort of trying to be the same all the time, you got a better chance at being the same all the time.
the smokeless, single base powder and raw powder and rocket powder. Where is, for the military, where is that being made today?
Well, ball powder's made at St. Mark's, Florida, where the hurricane hit. But everything is okay. It better be, because they make something like 85% of the military's ball powder is made there. And at Badger, we used to make only 4 different kinds of ball powder in big quantities. But down at St. Mark's, they make up to 155 now. It's filled with ball powder. I mean, there are a lot of things that ball powder is used for nowadays. And rockets are made, I think it's that Sunflower, but not the quantities that we're talking about, because they didn't have enough modernization, I guess. And the world is short, the free world is short of rockets that we made. We made dumb rockets. I mean, you just shoot a lot of them and they go where they go. Not the ones with computers on them that you can direct them to exactly where. So our rockets were $400 a piece maybe, whereas the smart ones are 40,000 a piece. Big numbers.
Philip on Zoom asks, during Vietnam.
Is that Phil all, Peter?
Yes.
Well, I don't know if I want to answer his question.
So during Vietnam production, was NC line E used to nitrate cotton for the Navy?
I don't remember that. It might have been. He wanted to know if NC line E was. Right. Do you know, Verlin?
I didn't think we ever ran during Vietnam. We might have run for a short time for some tests, but production would be VNC line period.
Yeah, I don't know if we've ever made nitrocellulose for a specific arm of the military.
As the amount of area became smaller, like for NC, you eliminated that whole area in the northwest part of Badger and concentrated it into the TNT area, right? What was gonna happen to that land? Were they gonna take down those buildings or keep them up for backup? Or it's a lot of buildings that wouldn't be needed anymore.
I don't remember ever discussing what's going to happen after we get this modernization done. I don't think we thought, at least we never thought that far ahead. But yeah, things would look a lot different nowadays. There probably wouldn't be the biggest tree, wouldn't be there. But I don't recall any discussions or anything about what happens after. It surprised me when I saw in the drawings, the new administration building. Well, what was wrong with the administration building we had? We were going to have this 5-star shaped, new administration building. It'd been nice, but, yeah.
What was the thing that made you the happiest of all of the things you did on modernization? What were you most proud of?
Well, I liked the nitroglycerin. The design and development of that. We chose to use the BHG design. St. Mark's, Florida has a Swedish design. Now, I didn't like the St. Mark's nitroglycerin plant because they put a centrifuge where they separated the nitroglycerin from the spent acids, a centrifuge with a shaft swirling around like this. And I always had problems with nitroglycerin sneaking down into the bearings. I did not like that. But they only, in the reaction vessel, they only had like 2 pounds of nitroglycerin, very small amount, whereas the BHG is more like 20 pounds. But the BHG had just a swirling around. No moving parts other than the material. And to me, that was extremely safe compared to the St. Mark's. So I got other people to agree that this is what we ought to do. It's safer. And 15 years later, I see it published in the military documentation about this is what we should have. But Radford, they had the Swedish way of doing it too. But they also then understood that the Swiss way of doing it is much, much safer.
We talked about the Badger kind of devising its own design for rocket beyond what was proposed. Who did that? Who did that design?
Our design,
Yeah.
engineering department.
You and the people you work with.
Yeah, me and my people.
Yeah.
Yes. And we did it, we completed it, but we never did other than startup. I didn't understand that process, though. It went down to sunflower. And I think they use it today. Yep,
Well,
you got a question?
I got lots of them. Oh,
I think it's a quick one.
okay.
How many employees did Frank have?
How many do I have, Roland? How many people work for me?
I didn't hear
How many people worked for Frank?
I know at one time I had the lab. Well, and
Just make up a number.
I remember, speaking of lab, I remember, you young ladies and the older ladies, you didn't get along that well. And there was always these ladies doing their little cliques. So I solved that problem by giving George Salaby the opportunity to resolve those problems. Yeah, and he took care of them. I would say, I'd throw out a number, maybe 40, 50 at the most. I mean, other times we got more specific, maybe down to 15, something like that.
Well, that's good because friction can cause heat. And when you're working with propellants, you probably don't.
Oh, I'm in the energetic materials business because you're not supposed to use the word explosive. Energetic materials is what Badger made. Well, that's true.
Okay, well. That's great. So thanks, Frank. That was lots of questions. I mean, you think about what's going on in the world today. And if that plant would have gone through all the modernization, I mean, part of it, it would probably be pumping out stuff right now. And think of what our area would be like for the good or the bad. But it would be a different area, that's for sure. So it's interesting to think about. All right, well, our next lecture in this series will be November 14, right here again at 6:30. And that's an evening with Operation Fresh Start. Operation Fresh Start is an educational, what do you call them? A business that gives opportunities for young people. And they have one department that's conservation, giving people training in conservation. And they have been out and they did about a week of work on conservation projects at the plant back in August or something like that. So that should be interesting. That's more on the Conservation Alliance side of things. We're kind of switching off every lecture. Then we're going to skip until February in case we do get snow this year. Those are December and January. We will not have a talk, but we'll be back at it again on February 13th. And so I hope to see you all here or on Zoom on November 14. So that's it.